In this video, I want to look at the greatest common factor, often denoted by GCF. This can also be called the greatest common divisor, or the GCD. The idea is it's the greatest counting number that is a factor of all of the given counting numbers. So let's look at an example. Let's consider the numbers 12 and 18. The factors of 12 are 1, 2, 3, 4, 6, and 12. The factors of 18 are 1, 2, 3, 6, 9, and 18. And if I look at this list, the largest number that is in both of the lists is 6. So we can see they do have a set of common factors, things that are in common with both of them. They both have a 1, they both have a 2, they both have a 3, and they both have a 6. But the 6 is the largest, so the GCF would be equal to 6. And this right here is one of the methods for finding our greatest common factor, listing out all of the factors and seeing which one is the biggest. But let's look at some other methods. Let's look at what's known as the slide method. The slide method is very useful when I'm trying to find the greatest common factor of really big numbers. Let's look at the greatest common factor of 8,800 and 10,000 using the slide method. In order to use this method, I'm going to build this table where these two numbers are my second and third column, and then I'm going to fill in the rest of the table, the first column and the rest of these. I need to think about what numbers these have in common. So what number divides into both of these? Well, they both end in a 0, so 10 does. 8,800 divided by 10 is 880. 10,000 divided by 10 is 1,000. And then I repeat this. What number divides into both 880 and 1,000? Well, once again, 10. 880 divided by 10 is 88. 1,000 divided by 10 is 100. Well, they're both even now, so I can say they have a 2 in common. 88 divided by 2 is 44. 100 divided by 2 is 50. Once again, they have a 2 in common. 44 divided by 2 is 22. 50 divided by 2 is 25. And now we have nothing else in common. 22 and 25 do not have anything in common. And this first column here is going to give me my GCF. So in this case, my greatest common factor, 10 times 10 times 2 times 2, or 400. So the greatest common factor here is 400. Depending on where you start with your slide method table, you could have this be really quick or really long. As an example, the last one, I noticed that they both had a 10 in common, but maybe instead I noticed they both have a 100 in common. That leaves me with 88 here and 100 here. Maybe now I notice they both have a 4 in common. 88 divided by 4 is 22, 100 divided by 4 is 25. And so now I would just have 100 times 4, which is still 400. So essentially what we're doing here is we're repeatedly taking out common factors until there are no more common factors left, other than 1. And then when we multiply all the common factors we collected, the product should give us the greatest common factor. And by listing our quotients over here on the right-hand side in this table, in our slide method, it ensures we don't repeat a common factor that we've already accounted for. Next, I want to look at the prime factorization method for finding the greatest common factor. As an example, let's consider 120 and 156. The first step on the prime factorization method is to find the prime factorization. The prime factorization for 120 is 2 cubed times 3 times 5. And the prime factorization for 156 is 2 squared times 3 times 13. And now once again, we're looking at what they have in common. They definitely both have a 3 in common. And this one has 2 2s. This one here is 3 2s, which tells me that they both have 2 2s. This one has an extra 2, but they do both have a 2 times 2 inside of their prime factorization. So the actual greatest common factor would be just multiplying these things they have in common. 2 squared times 3 is 12. Another way to think about this, other than just looking at this list and trying to figure out what they have in common, is a Venn diagram. For a Venn diagram, we have 2 circles, one for each number. So we'll let 120 be the circle on the left and 156 be the circle on the right. And then we just write down all of the factors. The middle part is what they have in common. So 120 has 3 2s, so I can do 1, 2, 3 2s. It also has a 3 and a 5. 156 has 2 2s, a 3, and a 13. So now we just multiply the numbers in the center piece, 2 times 2 times 3, which gives me 12. So that would be my greatest common factor.